Okay, picking up. We're talking about vertical stretching and shrinking. And we got that same silly shape that I've been working with a lot. We'll do the same thing. We'll move all these points over here. So that's -2, 1, -1, 1, 1, -1, 2, -1. So -2, 1, right there. 1, -1, 1, 0, 0, 1, -1, 2. Okay, so there's the original guy. And then answer in green. Spelled green wrong again. Don't know what the deal is about spelling green wrong. So y equal 2f of x, it's a vertical stretch multiply y coordinates by 2. Okay, so this first guy, we're just changing the y. The y coordinate currently is 1. Multiply it by 2. It's going to go to 2. Next guy, y coordinate is currently 1. Multiply it by 2. I'm going to get 2. This guy, y coordinate is 0. Multiply it by 2. Still 0. And I'll make it big so we can see it. Y coordinate y coordinate -1, multiply by 2, -2. Y coordinate -1, multiply by 2, -2. So all I did was take each y coordinate, multiply it by 2, then connect the dots, and there it is. And we can see that the problem, it just kind of got taller. It got stretched. Same thing on the next one. Answer in green. Y equal 1/2 f of x. That's going to be a vertical shrink. Multiply y coordinates by 1/2. Now this one's going to be harder to see, and I don't think I'm going to put the blue graph on there. So we'll kind of still, I'm going to put the points over here. So -2, 1, -1, 1, 0, 0, 1, -1, 2, -1. And so I'll leave the blue over here because things are going to get really small here. So again, just multiply every y coordinate by 1/2. So I'm going to have the point -2, 1/2 right there. Okay, go to this point. Multiply the y coordinate by 1/2. So it's going to be -1, 1/2 right there. 0, 0. Multiply the y coordinate by 1/2. That doesn't change, so it's still going to be 0, 0. Down here, multiply the y coordinate by -1/2. So it's going to be 1, -1/2, right about there. And then multiply the y coordinate by -1/2. So it's going to be 2, -1/2, right about there. And that's the answer. And again, it just got shorter. It shrunk. So a positive number out in front, vertical stretch or shrink. If the number is greater than 1, stretches. If the number is less than 1, between 0 and 1, shrinks. Now, if it's also negative, it also does the flipping. Okay, last page in this section. Use transformations to graph the following. So, thought process. Basic shape. The cube. Which looks like that. The +6 inside, that's horizontal, goes opposite to what you expect. So left 6. The negative in front, flips across the x-axis. The 4, vertical stretch. And lastly, the -2, down 2. Now, what will I be expect to see come test time on a paper test? So left 6, do that over again. Left 6, 1, 2, 3, 4, 5, 6. Down 2, 1, 2. So that's that center point. Flipping it, so instead of sort of starting on down, starting low, it's going to start high. Now the vertical stretch. Unless I want to get into really nitpicky things where you have to actually plot a whole lot of points, you can't show vertical stretches with these kind of quick and dirty graphs we're doing. And you can't show vertical stretches or shrinks with these quick graphs. Here where I went point by point and did it, yeah, we were able to demonstrate vertical stretch and shrink. But unless you're going to go point by point so you can really see about multiplying the y coordinate by that number, you can't do it quick and dirty. So come test time, all I would expect you to possibly consider about the vertical stretch is that you'd write it down, that you know that it'd be a vertical stretch, and then maybe you attempt to make your graph look stretched. But all I'd really be expecting to look for a graph here, I would be the flipped part, so instead of starting down, it's going to start up, and then it's going to look like that. And again, quick and dirty graphs, I can't really show the stretch or the shrink. And so come test time on a paper test, that'd be okay. Again, if I could show you my computer, we would do a problem so you could see how things are working on the computer. And all I can say is if, you know, I'm preparing these lectures for fall 2020, and we just don't know what's going to happen with COVID-19 and whatnot. If things are relatively normal and you can come see me, and if things are relatively normal, I'm going to demonstrate this in class. But if things aren't relatively normal and you have to get help somehow, you know, reach out to me email-wise, and maybe I can send some screenshots or whatever. But if you have problems making the computer work, just reach out for help. Okay, last problem in this section. Got that same thing again, those same points. Graph this last guy, y equal f of x plus 2 minus 4. The plus 2, which is inside, goes back opposite to what you'd expect. Left 2, the minus 4 on the end, not on the inside, down 4. So again, I'm going to take each one of those points. I'm going to put them over here, see what they are. So in blue, the original guy. Then I'm going to take each one of those points and just do what I have here. Left 2, down 4. So this point right here, left 2, 1, 2, down 4, 1, 2, 3, 4. There's the new point. Taking that point right there, left 2, 1, 2, down 4, 1, 2, 3, 4. There's the new point. Taking that origin point, left 2, 1, 2, down 4, 1, 2, 3, 4. There's that point. That one, left 2, 1, 2, down 4, 1, 2, 3, 4. And lastly, left 2, 1, 2, down 4, 1, 2, 3, 4. Connect dots. And there's my graph. And that's the end of this section.